So here's number 5 from the Chapter 5 AP packet. And it says, a car is traveling on a straight road with a velocity of 55 feet per second at t equals 0. From 0 to 18, the car's acceleration, a of t, is in feet per second squared. And it's a piecewise linear function defined by the graph below. So, really quickly, everybody has to remember that this is the graph of a of t, the acceleration. And the fact is that when I give you the acceleration graph, the area underneath the curve and above the x-axis, that will always represent the one antiderivative of that. So if I can remember, position, take the derivative, goes to velocity, take the derivative, goes to acceleration. If I start with acceleration and I'm finding area, that will always represent velocity. That's really key for this entire problem. So part A, is the velocity of the car increasing at t equals 2 seconds? Why or why not? Well, if I'm asking if the velocity is increasing, I really want to know if velocity, which is v of t, if that would be increasing, v prime of t would have to be greater than 0. Well, I go back up to this. If I have velocity, but I want the derivative, that would be acceleration, which is what the graph provides you. So v prime of t is equal to a of t. So the question is, what's going on at 2 seconds? So v prime of 2 will equal a of 2, which according to this graph is 15, which the most important part about that is that it's a positive value. Do not look at this graph and see, oh, there's a flat line, so the velocity is constant. No, the acceleration is constant. However, it is still accelerating, so therefore the velocity is increasing. So since v prime of 2 is greater than 0, the velocity at time t equals 2 is increasing. Part B, at what time in the interval from 0 to 18 other than t equals 0 is the velocity 55 feet per second? So you have to read into this a little bit more than how it shows you. It's saying at what time in the interval, which is implicitly saying that there is a time in the interval, and really there's only one time in the interval. So what I need to do is figure out, okay, at v of 0, the car was traveling 55 feet per second. But as soon as I started and the clock went off, the car was accelerating. So if I wanted to break this down just for one example, let's go up to 2. Since this is the graph of acceleration, the area represents velocity. Well, if I look at the velocity, 2 times 15 is 30. So v of 2 equals 30 plus 55. Because it's the velocity's displacement plus its initial velocity. So since it was accelerating from 55 and it accelerated a total of 30 feet per second, now we're at 85. So logically, you can see all of this above the x-axis is acceleration. So this was 30, and if I do 4 times 15 divided by 2, I have an additional 30. So looking at the graph, you have to break down where will I undo what I just did. I added 60 to the velocity. When will I subtract 60? Well, make it easy for yourself. The area of this piece is 30, but since it's below, I would be subtracting. So the question is, how much more do I need to subtract? I need to subtract an additional 30. Well, since the height remains to be 15, I need a base of 2, so this will be an additional negative 30. So we can say at time t equals, let's see that we ended at 12 seconds, the car will be traveling 55 feet per second. And the question is, why? How do you know? Well, don't just say area. Don't refer to area. Don't refer to any sort of ideas that kind of came into your head that doesn't explicitly show you that the velocity is back at 55. What I really want to show mathematically is that the area had to cancel out. Don't write area as canceling out, but do write the integral from 0 to 12 of a of t dt equals 0, and therefore v of 12 will equal 55 feet per second. You do need the integral because this is the one that explicitly tells you the math behind it. On the time interval from 0 to 18, what is the car's absolute maximum velocity and at what time does it occur? Okay, anytime I see an absolute maximum velocity problem, absolute maximum whatever problem, always refer to either it's going to be a table or a sign chart. How do we know? We look at the interval. It's a closed interval. So I immediately draw a table for myself. Here's t, and here is v of t. Now, the reason we use v of t is because we're looking for the maximum velocity. So the question is, what do we put for t? Well, if you remember, we need all our critical points and all our endpoints. Our critical points, in this case, would be when v prime of t equals 0. If I look back at my chart, v prime of t equals 0 at 6 and 16. 6 and 16. My endpoints are 0 and 18. Now, what do I know? I know my velocity at 0. I know that's 55 feet per second. How about all the others? Well, let's start with 6, because that's the first one. I sort of already described what's going to happen at 6. I'm adding 30. But show the computations that are going to lead to that. So it's 55, because that's your initial velocity, plus the displacement from 0 to 6 of a of t dt, which is really going to be 55 plus, and the integral from 0 to 6 was 60, so this gives you 115. 115. Next, if I want to find the integral, or the velocity at 16, I have to do 115 plus the integral from 6 to 16 of a of t dt. So this will be 115 plus, but what's this integral going to be equal to? Well, we have to go back up here. We have to figure out, okay, what is the area of all of this that's underneath the x-axis? If I count it, that first part was negative 30, the second part was negative 30. Here is an additional negative 30, but here is only an additional negative 15. Add that all up, negative 90 plus negative 15 is negative 105. So minus 105 equals 10. So the velocity is 10. And finally, what's happening at 18? Don't ignore that because that is an endpoint. So then we'll go 10 plus the integral from 16 to 18 of a of t dt. So that'll be 10 plus, and let's go back up here. What is the area of this? It's 2 times 15 divided by 2, so add an additional, 15 equals 25. Okay. So now we go back and we say, let's just get this out of the way. At what time does this occur? At t equals, what was it, 6, the max velocity is 115 feet per second. Now the reason we need both is because it actually asks for both. On the time interval, what is the car's absolute maximum velocity? And at what time does it occur? You need both. If you don't have both, you won't get all the points. Now, you don't need to mention that the sign changes. Your justification comes from the table. And a table is a standard practice of finding the absolute maximums. Now, the fact that we did this is going to help us in Part D. Because in part D, it says, at what time in the interval from 0 to 18, and if any, is the car's velocity equal to 0? Justify your answer. The answer is never. The reason is, you can see from the table, the absolute minimum velocity is 10 feet per second, and therefore the velocity will never be equal to 0.